While we spend a lot of time learning how to improve our staining technique, it's equally important to remember that all those best efforts to achieve good stains can be rendered useless if you come into problems like this. So in this case here, just during the final cover slipping, some mounting medium has got on top of the slide, and in the process, it makes it very difficult to see what's going on underneath. So there could be valuable diagnostic or research data of value that is therefore lost. So what's the best way to ensure that you are cover slipping your slides in a reproducible manner without any issues? Well, if you happen to work in a laboratory that's routinely processing large number of slides every day, you'll probably have access to one of these automatic cover slippers. But even in the case of these devices, they often can and do sometimes have problems. And so having a knowledge of how to manually mount cover slips is a really useful skill for any histologist. So what is the best way to manually cover slip slides? Well, it's important to say at the outset that there really is no one best technique that everyone should follow. Like most things in histology, cover slipping is an acquired skill, and I think the best way for people to learn is by observing different techniques from more experienced colleagues, and then gradually over time you can perfect your own personal technique. Just to highlight some of the issues that can occur during the learning process, we've got a series of slides here from some former students, and they each demonstrate, I guess, a series of improvements which are pretty typical of students as they begin to improve upon their cover slipping technique. Beginning with this first slide here, you can observe towards the top left-hand corner here that insufficient mounting media has been applied during cover slipping, and so that's resulted in this large air pocket being present, including a series of smaller bubbles that are covering the specimen itself. Now, because of that, you can't really observe sufficient detail within the specimen, and so this slide has little to no diagnostic value, and so that combined with the quality of the stain that's been applied has resulted in a score of 40%. Now, as students begin to improve their technique, they're generally approaching something a bit more like this slide. This actually scored 8 out of 10 or 80%, both based upon the quality of the stain, but also the cover slipping here has got some minor issues associated with it. Now we see there's not so much of a problem with adequate mounting medium, but the slide has drifted a bit in those first few minutes following being cover slipped, and that's resulted in the cover slip just marginally hanging over the edge of the slide a little bit. So it's not affecting the ability to achieve a diagnosis. However, that minor issue could have been corrected for, and whilst it's not really a sort of major issue, but it is quite important from a health and safety point of view to not have bits of glass hanging off the edge there. Then in time, having had a bit of practice with this technique, most students will be able to fairly routinely achieve an outcome such as this one here. So this is a slide that was cover slipped during the final staining exam last semester, and you can see there that there's, first of all, there's no mounting media on top of the slide, importantly nothing on top of the specimen itself, and there's just the right amount of mounting medium filling the rest of the slide, and it's not drifting off to the side. So that's really ultimately what everyone's aiming for each time, and in combination with some really good staining on this occasion for melanin using the Schmoll's technique, this student was actually awarded 100%. So what are the essential steps to achieving good cover slipping every time? Well, I can't stress enough that really it's important to observe different demonstrations of slightly varying techniques from different more experienced colleagues. But what I've put together here is a I guess, my list of tips for achieving good cover slipping. And this is a series, I guess, of checks that I've developed over time based upon my own opportunity to observe more experienced people. And this is what works well for me, and this is basically how I describe the process to students as they're learning this process. So I'll begin with this verbal description, and then we'll subsequently show an actual demonstration of this technique. And then at the end, I'll show you some examples of how things can go wrong if these steps are not always followed. So the first step, which seems a little bit obvious, but it is quite important, and that's to make sure that you're only applying one cover slip to the surface of your slide. Why would you, or how would you end up putting more than one? Well, they can often stick together, and especially if you have some mounting medium or some xylene even on your glove, they can quite easily stick together. And why that's a problem is that, as we'll see later on, having two cover slips on front of the specimen does significantly affect the optics, and it makes it more difficult to see your specimen clearly under high power objectives. Secondly, you need to check the viscosity of your mounting medium. Now, you're not going to measure this to any degree of uniformity each time, but in a practical sense, you just want to ensure that your mounting medium hasn't dried out and that you can reliably squeeze out the volume of mounting medium that you need. If it's too dry, that becomes more difficult, and it does affect the flow of the mounting medium across the surface of your specimen. So you'll get a feel for this over time, but if in doubt, if you tilt your bottle and find that it's hardly moving at all or moving very slowly, then it's a case of either having to switch to a different bottle, to a fresh bottle, or you can dilute the mounting medium with some xylene and give it a good mix so that you achieve the right level of consistency. And this is actually closely connected with the next statement, that the technique requires some xylene to be retained on the surface of the slide. And so really in principle, what you're aiming for is good integration of the xylene that's covering the surface of the tissue with the xylene that's present within the mounting media itself. And so in doing so, you'll find the mounting media will move promptly across the surface of the specimen and hopefully reduce the opportunity for bubbles to be present. Now, with respect to ensuring that you're applying just the right amount of mounting media, the strategy that I find useful is to apply a thin line of mounting medium approximately 5 millimeters inside the long edge of the cover slip. And I'll show you a picture of this later on as I'm doing it, just so you can better visualize what that actually looks like. Then finally, it's good advice, I think, to give people when they're starting out to only cover slip one slide at a time. But what I mean by this is that, say for example, you have 10 slides that need to be cover slipped. Well, rather than laying out 10 cover slips and putting your rows of mounting media on each slide, it's better to do one at a time, because what you'll find is that if you have multiple cover slips with mounting media on top just sitting there, you'll find that by the time you get to that last cover slip, because the mounting medium is dissolved in xylene and some of the xylene can evaporate over time, it's possible to get a thin crust of plastic that's formed. And so then when you subsequently press down with your cover slip onto the slide, you can find that layer of plastic can shatter, and those little particles can be visible when you look at the slide under the microscope. Okay, so now actually moving to the process of cover slipping itself, it's hard to believe that a technique as simple as this would actually involve so many different components to it. But these are actually the thought processes that I go through each time in order to achieve what I feel is a good level of cover slipping, 99% of the time. So what are these steps? Well, I'll just briefly go through these now, but they'll actually make more sense to you when you see them being demonstrated. Okay. So the story that I tell myself as I'm actually doing this is that it's about moving promptly from the minute of lifting the slide out of the xylene to the final point that you lay the slide down to be dried. So beginning with light touch of the end of the slide to remove some of the excess xylene, but not too much. Moving the slide to its side, bringing it close to the edge of the cover slip, closing it down like a hinge, forming against the edge of the cover slip, allowing the mounting medium to connect and then spread approximately 50% of the way across the slide. And then as you do that, you keep your thumbs underneath the front edge, and this will make more sense when you actually see it. And the reason being that if you allow it to fall flat at that time, some of the mounting medium can actually come out from underneath between the slide and the cover slip and can actually make its way onto the front side of the cover slip. Okay, then you flip it over, and as you flip it over, now you've got the cover slip facing face up, and capillary action should then ensure that the mounting media, being of the appropriate viscosity, mixing with the xylene on the slide, should actually move promptly across and cover the specimen and make its way to the far edge of the slide. You then pick it up, you wipe off any excess xylene that might be on the back of the slide, check for any air bubbles at that point. Now if there's a couple of tiny bubbles that are nowhere near the specimen, you don't really need to worry too much about that. Clearly it's not going to have any effect diagnostically or in terms of any research applications if it's not covering any of the tissue. But if they are, then you then need to promptly move those by squeezing. So you press down on the top of the cover slip to push them out towards the edge of the slide, and so that they're no longer covering the tissue. So to do that, you obviously want to use either clean forceps. You don't want to accidentally put mounting medium on top of the slide. And so we often use, as you'll see in the demonstration, these thin sticks of timber, which they're clean and they provide a convenient tool for squeezing out any air bubbles. Likewise, these sticks provide a really useful tool for just making any minor adjustments to the straightening of the cover slip. So as I mentioned before, you don't want the cover slip to be sliding off the edge of the slide such that you've got a pointy bit sticking out. So if necessary, you can just use these applicator sticks to just straighten up the cover slip. And then finally lay the slide flat so that there's no further movement of the cover slip, and just leave it in a well ventilated area until it's dry enough to be handled and looked at under the microscope. Okay, so now having gone through all the theory, hopefully you haven't gone to sleep, but now let's look at an actual live demonstration of this process. So here I am just checking to see that I've only got one cover slip, and actually I can just make out there's a few stuck together. The camera doesn't quite pick it up, but I've noticed that there's a couple stuck together, and sometimes you get a diffraction grating visible to the naked eye. So I just need to separate those out so that there's only just one. And in fact, I think there might have been three that were stuck together on that occasion. There we go. So I've got my one cover slip ready to go. Okay, so having ensured I've only got the one cover slip, I'm now just checking that I've got everything else I need. I've got my Coplan with my slides, I've got my mounting media. So let's just take off the lid and I'll check the viscosity. I can see that that's flowing backwards and forwards sufficiently that it should flow nicely. So this is where I just apply a very thin line of mounting media, and you can see there in the diagram what I'm aiming for there in the blue is the approximate width and length of the amount that I'm dispensing just inside the edge of the slide. So then moving promptly, pull the slide out, touch the toes, lay it on the side, bring it to the edge and make a hinge. Gradually close the hinge until you get connection with the mounting media coming across to about 50% or so, thumbnails underneath, and then flipping it back over, and then let the capillary action draw the mounting medium across the slide. Because there's xylene on the slide and a good amount of xylene still in the mounting medium, it's just flowing nicely. Then wiping the back of the slide to remove any residue, and then check for bubbles. Now there is in fact a small bubble that has formed, and you can't quite see it yet, but using the applicator stick you'll see in a moment. I've just identified it there and I'm squeezing it out. Just move it slightly different angle, you'll see it now I think. Okay, small bubble there, squeezing on top with the dry stick, and then it's moved away. Now that bubble was nowhere near the specimen, but it's just to demonstrate that technique in case you need to do it. Then make a final adjustment, making sure it's on straight, and then laying it flat, and just let that dry. Okay, so let's look at some outcomes. So here is a section of liver showing a central vein there, and we can see that things look pretty good, nice and clear under the 40x lens. However, if we had accidentally applied 2 cover slips, and this is not the same section, but it's a serial section stained at the same time, the same location within the tissue, having that extra cover slip actually makes that look less clear. So yeah, the optics of the scope are designed such that you're looking through air, then through to glass, through to mounting media. If you have that extra layer of air sandwiched between the 2 cover slips, then it gives you that kind of cloudy appearance. Now if we move back to the first slide, which had only the single cover slip, and I've now moved to a 100x oil immersion lens to demonstrate this next issue. So here, the slide that's been cover slipped correctly, we can see some good detail there, and pay particular attention to the morphology of the nuclei, which have been nicely stained with Ehrlich's hematoxylin. So now compare that to the next slide, where now if you observe closely you'll see that some of those nuclei now look black, and this is simply due to having allowed too much of the xylene to evaporate from the surface of the slide before it's brought down onto the mounting medium. So best as we can actually understand this is that as more of the xylene has evaporated, that's resulted in these small air pockets within the detailed chromatin structure within those cell nuclei, and then as those air pockets get trapped beneath the layer of mounting media, when you then look at it under the bright field microscope, it's just having this effect on the optics such that now those areas look dark when they should be looking just as blue as those other cell nuclei. So this just re-emphasizes the concept of bringing those slides promptly out of the xylene, removing just a little bit of the xylene, but you don't want to overdo it, so you don't want them sitting in a rack becoming completely dry before you move to the next step. It really is important to retain a layer of xylene on the surface of the tissue. Then finally, for this last example, we'll move back down to a low power field of view, and it's pretty obvious what the issue is here. You can see there's a nice spherical air bubble present within the central field of view. So that just really prevents your ability to obtain an even field of focus. You can of course just focus down through that to see what's going on within that central field, and so perhaps it's less of a problem from a diagnostic point of view. But for either a research or a diagnostic application, if you're looking to photograph a field of interest, you don't want for there to be a large bubble present there. So this is an example of where you simply take your wooden applicator stick or a dry pair of forceps and squeeze on the top of the cover slip until you've chased the air bubble out to the edges while the mounting medium is still reasonably wet. So there you go, that's my philosophy on cover slipping. It's hard to believe I could spend 20 minutes talking on this topic, but I think probably the most important take-home message here is to just practice look at different examples from demonstrators, teachers, more senior colleagues, and then ultimately the best cover slipping technique is going to be the one that works best for you. But over time, you'll be able to go from something like this to something like this, and it's just a really useful skill for all histologists to have.